Hi everyone, today we are going to present the app Safety LA we developed. Safety LA is an application to help LA visitors avoid hazards and secure their safety. We explore the safety levels of the city of Los Angeles according to the statistics from LAPD police stations and provide users with a reliable source to check on more detailed crime-related information. The functions of our app include the safety guide and map, the ranking of safety levels in a certain area, the visualization of high-risk areas, the filters for users to choose the attributes they want to focus on, and etc. Our project is also designed to change local stereotypes. Neighborhoods which are associated with unsafe impressions because of film and television works might actually be safe. On the other hand, we provide the updated data that demonstrate the safety levels from a more subjective perspective. And next, James will talk about the data flow of our project.
So we download this data set, crime data from 2020 to present from Los Angeles Police Department database. And this is a CSV file. So we actually use the SQL database to store our data that are used in our app. How we do that is we download the MySQL Workbench and MySQL Community Server. And in MySQL, we create a new server, and in that server, we establish a new schema. And then we import the CSV file into that newly created table. And this is how it looks like in MySQL Workbench. And I tested a couple SQL queries here to check whether the data is working. So after we're making sure that the data is already in MySQL database, we connect the MySQL database to Streamlit by using the Python and MySQL connector that Professor talked about during his lectures. It's just this 2 lines of codes. And after that, we successfully connect our MySQL database to Streamlit. So we can now write SQL query in Python. And then I will briefly go through the structure of the code of our app. So basically, we have our app divided into 6 pages. The default page is our homepage. And then we have the rank functionality, the visualization functionality, the filter functionality, about and contact us page. We use one of the Streamlit API called sidebar select box to make the menu. So it will appear on the left side of the app where users can select which page they want to go. So if the user select homepage, this area is all the code supporting the homepage application. First, we read the CSV file to Streamlit and then display the raw data. And then we change the 2 columns to lowercase so that we can use the Streamlit API st.map to display the visualization map of our raw data. And after that, we write a bunch of SQL queries to display criminal information, criminal activities information for different areas. And it goes on and on. And after the homepage, we'll have the rank functionality. So rank functionality is also built on MySQL query. We first ranked the safety/danger level of each areas according to the total number of crimes. We also ranked the safety level according to 4 other major type of crimes, including felony, homicide, rape, burglary, and vehicle-related crimes. And then we kind of calculated a ratio that we designed called crime to population ratio, and we displayed all the crime to population ratio for each individual regions here by this chunk of code. and we manually ranked those ratios here using the list. And here is the chunk of code supporting the visualization function, which is designed by Catherine. Here, I believe she also used a Streamlit API called PyDAC chart. And in this section, Sarah designed the very important filter function, which also used the Streamlit API called multi-select. It gives users a chance to add whatever filters you want to add, and just filtering the criminal activities data through their filters. And at last, we have the about page and contact us. It's pretty simple and not much to explain here. And then let's go to our app. So welcome to our app. As a user, let's say I'm an upcoming USC freshman who is new to the city of Los Angeles and wants to get a general idea of the criminal activities here. Homepage is where I will come first. And this is also the default page every time someone visits our app. At the top, I can see the raw data source display from LAPD so that I know the app is using a reliable source of data. Then after the raw data source display, I can see a map that visualizes the data for me. So I can see where criminal activities are really concentrated. I can zoom in the app to have a better understanding of where criminal activities are concentrated. And I can also use the timeline slide bar to adjust the time range selected. So let's say I care crime happening within 1 month. I can adjust the timeline to do so. And the visualization map will change accordingly. And according to the map, you can clearly see that criminal activities are pretty concentrated in the central area. Oops. And after the visualization map, this is where user can get a little bit more detailed information about each individual regions. And we have 21 regions in total in the city of Los Angeles. And these regions are differentiated by LAPD stations. So in LA, we have 21 police stations in total. And these criminal activities data are specifically to that region. So let's say I'm a USC freshman, of course, I want to look at the data in Southwest area as USC locates in Southwest. So I'll use the select box to select Southwest. The tables below will also change accordingly. Now, all this information are related to Southwest area. I can see the total number of crimes happened in this area and the detailed information of those crimes. I can see how many felonies happening in Southwest, vehicle-related crimes, criminal homicides, robbery, burglary, stealing crimes, and also rapes. And after that, if I want to get a little bit deeper into the data, I'll use the filter function, and Sarah will walk you through that.
Yeah, so I will introduce the filter function. So this is our crime filter page. User can randomly select the filter they want here in the slider on the left. And we have several filters. You can see we have filter on the area, and also we can select the crime type. And yeah, we can just scroll through that to let you see that. And also we can select the victim sex and the location. And then we can select the timeline, also the victim age range. Yeah, so let us just imagine a scenario. Like if I'm a user and I'm an incoming USC student who really concerned about my safety issue in LA, but kind of unfamiliar with the place and knowing nothing about how safe it is around the USC campus. So what I need is I need to select a Southwest area, and then I will select the crime type I was interested in. So for me, I was interested in all vandalism. So I will select those two. And also I'm interested in the shoplifting and the burglary and the thief plan, and finally the robbery. Yeah, this is all crime type I would interested in. And because if I'm a female student, so I'm personally want to know the female victim side, so I was select female. And for location, I was interested in street, sidewalk, street, and multi-unit dwelling, and also hotel, and also vehicle passing. And so I also like interested in all the timeline years, so I just moved it to include all 2 years. And for victim age, because I'm a young adult, I was more interested in aging from 18 to 60. And so yeah, so just wait for a second. And on the left, we will see there's a table generated that include all the data that satisfy your filter. And you can just go inside the table and look inside the detail of each line to see the exact information for each crime case. And at the top, there's a total count of selected crime. So according to my selected filter, there's about 1,300 crimes in total. And we just calculate a cell danger level according to the total selected crime. And this is a level just we do some calculation and it's presented here. And for my select data, this like the danger level is roughly 4 or 3.5. Yeah, so this is just an imaginary case. Like if I'm an incoming student, USC student, and interested in the safety level around the USC region, they show how my need is satisfied. And as an incoming freshman, this filter function really helped to keep them safe in the place they might not be familiar with, and help me them to like avoid danger or estimate the danger level around the place they live. And maybe you can just select the filter like according to your own needs. Like maybe I was also interested in all population, so I could select all the sex, including male or actual or non. So just select all the data, and here, just wait for her to preset. And now we generate a whole new table, and for this time they have total select crime is 2,700 crimes, and the total select I think will become 7.1. So there's 7 score there, like it's increased the danger level because there's more total crime. So this is just our like a brief go through of our filter function. So let's move to the visualization part.
Yeah, so for the visualization part, we provide the users an intuitive sense of the safety level in different areas with the visualization of crime data. We utilize the PyData library to render and display the map of crime data in selected areas. Users can select the area they want to view through the filter tool. For example, if you want to get to know the approximate danger level of the area around USC, you can select Southwest at the filter bar. And as you can see, yeah, it may take seconds to process. Yeah, so as you can see, the highest column represents the location with most criminal cases. Also, if you want to compare the danger level of different areas, for example, if you want to compare the Southwest and Central area, by selecting them on the filter bar, and now you can easily find out that the Central area is much more dangerous than the Southwest with the higher column. So by using this function, users can have a basic understanding of the danger level of selected areas with just the simple steps. And now we can move on to the ranking function.
So the rank functionality basically provides users a very direct way of seeing the relative safety / danger level of different regions in the city of Los Angeles. We have a couple different ranks listed here according to total number of crimes and total number of major crime types. For example, felony plus homicide, rape, robbery, burglary, stealing, and vehicle-related crimes. And lastly, we have a rank according to the crime to population ratio within the region. And we have all the ratio listed here for each individual region. And we manually ranked those ratio here on the right side. And at the bottom, we have a safety index reference that can be used by users to check the relative safety level of their regions. And noticeably, central area is without a doubt the most dangerous area because it has only a registered residence of 40,000 people. However, in almost all ranks, Central ranked at the bottoms, as you can see here, here, and here. And of course, for the crime ratio, Central ranked at the bottom and nearly 0.7, which is like 4 times higher than the 12 than the second dangerous region. And yeah, that's a rank functionality. And at last, we have about page. This page basically provide users a basic understanding of why we did this project. It's all about our motivation. Users can quickly skim through the about page. And if the users want to contact us on more detailed information of how project runs and how we developed the app, they can definitely contact us through the contact us page. And back to the slides.
Yeah, so along the way we are doing the project, we have faced multiple challenges, and some are overcome and some require further exploration. The first noticeable challenge is to find the appropriate data sources. There are a lot of scattered and outdated data online. How to efficiently find the accurate and latest data set on the internet to support our later analysis is a challenge at first. We overcame this challenge by digging deep into the LAPD databases and managed to download a detailed CSV file that cover all regions' crime-related data. The second challenge was we had to learn how to use Streamlit from the ground up. The Python syntax in Streamlit is slightly different from what we previously learned. The environment setup and the alignment between group members also challenge us, but we finally managed to overcome these challenges through the good teamwork. So from the whole project working process, we also learned a lot from the challenges. And next, Sarah will continue to talk about our learning experience.
Okay, so I will just give a wrap up of our whole learning experience. So during the whole process, we really learned a lot of data science knowledge and also learn how to carry out a long-term project. So from the beginning, our group specifically interviewed people who live in LA and on what they think of current issue the city has. And based on the outcome, we believe that security and safety is the most concerning pain point, and it would be a beneficial product if we can land it and solve this issue. And the next step we did is to write the first edition of the proposal and develop the prototype using the Figma to support the concept. In this stage, we start to figure out a concept without a solid ground study, mainly based on imagination, will usually fail. Thus, a prototype is essentially the first important step to really land the project. We use our prototype to, after we just download the prototype using the Figma, we use it to survey a group of friends and classmates who live in LA, and we receive valuable advice and affirmation. Our group decided then to proceed with Streamlit to execute our function and build the app. While the Streamlit save time for the front end editing, it sacrifice part of the UI design. But we overcome multiple challenges which mentioned before. So looking work, consultation and research, and the overall learning experience can be summarized by thinking bold idea, test with discretion, and develop with all effort. So this all we got for our project, and this is the end of our demo video. Thank you so much for listening, and goodbye.